The very first and one of the important things in clean architecture is the dependency rule. It dictates that the source code dependencies should always point inward and not outward. In other words, the business logic should not depend on the external components, but it should depend on the core. This promotes separation of concern and decoupling. And the best part, you can check it easily as there are many tools available. Tools like Structure 101, JArchitect, or NDepend can provide visual representation of dependencies. For example, for your .NET applications, you can use NDepend and it will show you the visual representation of dependencies. And in this case, it's all pointing inward. Focus on the business rules and entities first, without considering the external details like database or frameworks. This ensures that the business logic is not tightly coupled to technical details. And the third is decouple frameworks. It is important. Wrap the framework-specific code and keep it separate from the main business logic. So the application should not bound to a particular framework. For example, in this ASP.NET Core Web API code, the controller directly accesses the database using Entity Framework. So, tightly coupled with Entity Framework, which is not really good. Now let me show you a refactored version. I use a service layer to decouple the business logic. In this decouple example, the user control is only concerned with handling the HTTP request. It delegates the logic of fetching to user service implementation. Now in future, if you ever decide to change your data access logic or even the way you store data, you only need to modify the user service implementation and the changes would not directly affect your controller. And the best part is not bound to any specific framework. This leads to the next point. Database is an external details. Treat database, frameworks, and third-party applications as an external details. Your core business logic should remain unchanged regardless of which database or framework you use. And my fifth point is use DTOs, data transfer objects. It is one of my favorite points. When moving data across layers, use DTOs. Why? Because they are simple objects and don't contain any business logic or framework details. And the next is avoid large classes. If a class becomes too large or starts handling multiple responsibilities, consider refactoring. Large classes often indicates design problems. Imagine you have a class called user manager in the system, and over time it's grown to include methods for both managing user information and handling user authentication, which is wrong. So by splitting this large class into two separate classes, each focused on a single responsibility, and you can achieve better maintainability, readability, and cleaner architecture. And that leads to the next point. Avoid global states. Global state can lead to unpredictable behavior and tight coupling. Instead, pass dependencies explicitly. Suppose you are handling an application that manages user profiles, and you have a class called user profile service, which uses a global state to access the database. It's really a wrong way, as it leads to tight coupling and unpredictable behavior. The right way is to remove the global state and pass the dependencies, iDatabase, explicitly to the user profile service via its constructor. And my next point is connected with this. Configurability over hard coding. Externalize configuration details. This makes your system flexible and adaptable without needing to change the core code. Let's say you have a simple application that needs to connect to database. Instead of hard coding the connection string, you can use the built-in configuration system in a .NET Core application. And your C# code will look like this. By using these configurations, you can easily change the connection string or any other configuration settings without modifying the core code of your application. And by doing so, it's also very easy to change the data source, which is my next point. Your core logic should be agnostic to the database. It doesn't matter if you're using SQL, NoSQL, or flat files. Why? For three reasons. Number one, flexibility. Changes in the technology or business needs might require you to switch databases. If your business logic is agnostic to database, it ensures a smoother transition. And number two is maintainability. Focusing on business logic without trying to specific database makes the code base easier to understand and modify. And finally, scalability. Different databases have different scaling capabilities. Being agnostic lets you choose the best that fit to your scaling needs at any time. And the next point is unit test everything. Ensure that each layer of your application, especially the core business logic, is covered by unit tests. This validates that everything is working as expected without depending on the external components. And the next is prioritize readability over shortcuts. Imagine a code that is not easy to read. It simply means it's not easy to maintain and easy to debug. Avoid short names or language-specific tricks. Why? If a new developer works on it, he might not understand what exactly this nickname means. Or let's say you have to work on the same piece of code after 6 months. You might not remember why I used this short name. That leads to the next point, consistent naming conventions. Use clear and consistent namings for classes, functions, and variables. This makes the architecture more clear and easy to understand. I need to reduce the learning curve, especially to new members. In fact, consistency is the king. If consistency is the king, do you know who is the queen? Clarity. And my next point is maintain a clear boundary. Separate the core logic from the user interface, databases, and external services. This separation, often represented by different layers in the architecture, it ensures modularity. And point 14 is immutable data structure. Wherever possible, try to use immutable data structure. They are less prone to errors and make the code more predictable. And the next is use dependency injection. This allows you to invert dependencies, making the system more modular and testable. It is really important. So let me demonstrate a simple example of DI using a very simple example. Imagine you have an iMessage service interface that provides messages services and two classes, email services and SMS services, implementing it. Now, let's say there's a notification service class that sends notification but does not depend on the specific messaging service. Instead, it takes the iMessage service as a dependency. With this design, notification service is decoupled from specific messages services. You can now inject either email service or SMS service at runtime using dependency injection. And the next is dry principle. Don't repeat yourself. Instead, reuse code instead of duplicating it. Suppose you have an application where you frequently need to log messages to a file. Without using dry principles, you might write the logging logic in multiple places, leading to repeated code. And by creating a log to file method, you can eliminate the repetitive logic code from processing data and process user input methods. And it will centralize at one place. This is not only reduce duplication, but also make easy to understand and easy to maintain. And the next is KISS. Keep it simple, stupid. Begin with a simple architecture and refine over time. Avoid overcomplicated from the start. And the next is YAGNI principles. You're not going to need it. Avoid over-engineering or adding features you think you might need in the future. Never do it. And the next is document architectural decisions. This is one of the valuable documents which you might have in your project. This is invaluable for both new team members and for revisiting decisions in the future. And my final point is limit parameters. The function should have at most 3 parameters. If you need more, consider using an object or data structure. Imagine you are building a function to set up user details. So instead of passing all the details as separate parameters, you can encapsulate them in a class. With this way, the function signature is simpler, more maintainable, and can easily accommodate additional fields in the future without changing the method signature. And here is a bonus tip. Never nest your code more than 3 levels. Nesting means when you place one code structure inside another. For example, if statement within if statement, or a loop within a loop, or a if statement within a loop, or vice versa. Did you know that nesting code adds a higher cognitive load to your thought process? This is a video that helps you to understand it better. And thanks for watching.